In this video, we're going to deal with the question of what is a computer. Now, if we were computer scientists or kind of hardcore philosophers, what we might do is to think about tricky things, like we might talk about Turing machines, which are interesting kind of conceptual devices, and we might think about the Church-Turing thesis, which is very mathematical. And I think if I were going to kind of write a paper or make some kind of serious contribution to the question of what is a computer, this is the kind of thing that people would talk about. But we are in an undergraduate psychology class, and so we're going to avoid this. We're not going to completely sidestep the question of what a computer is, though, because that would be unsatisfactory. If we're looking at the question of is the brain a computer, then we need to actually have some decent idea of what a computer is. And so this video will convey my own particular views, which may or may not be right. I think they're not stupid. But they're going to convey my own views on what a computer is. And I'm going to focus very much on the concept of a function. And we have to be careful of the word function because it's used in many different ways. So here I'm going to talk about functions in the sense of things that transform inputs to outputs. And this sounds very much like the black box that we've been talking about in behaviorism. So the inputs, for example, could be seen as sensory information, and the outputs could be seen as behavior. And in between, we have a black box. Equally, I could essentially just now say, well, we're going to use the word function as synonymous with a black box. So it's going to take some inputs, do some things, and produce some outputs. Okay, well that is very vague and that didn't really help. So let's try to flesh that out a bit. Well, we could think of Pavlov's dog, or at least Pavlov's dog's brain as being a black box. And so you could think that, well, this is receiving auditory input here in terms of the bell, and maybe it's also receiving visual input in terms of the arrival of food. And the output that can happen when these inputs are present could be salivation. So you could view Pavlov's dog's brain as being a black box which performs a particular function in a particular situation. Similarly, you could think of the brain, or more broadly the nervous system, as being a black box. And well, what does this black box do? It could map a series of inputs to a series of outputs. So that's, I think, all very straightforward. Incredibly general, but I think straightforward. What else can we think of as a black box? Well, I would argue that you could have many things. In fact, anything that computes could be in here as a black box. And so we could consider an artificial neural network. So the details of how this works is not important for our present purposes, but it's kind of interesting because artificial neural networks are simplified, abstracted versions of how we kind of think that real neural networks operate. So the whole point of neural networks, deep learning and so on, is to take a series of inputs and to provide a certain series of outputs. And if we have a neural network that has been trained in a certain way, then it will do kind of interesting and useful things under certain sets of inputs. So let's consider an actual concrete example now. So here we have a picture of our black box. So this is a thing, a computer which performs a function. And what I've done here is I've listed inputs and an output to try and keep this simple. So the two inputs are, let's say, the presence of beer or the presence of wine, and the output is going to be your mood. So in the absence, if we look at this top row, in the absence of beer or wine, then you might feel a bit sad. Maybe you've had a tough day. Now, you could have the presence of beer and the absence of wine, and the example there would be you're happy. Or you could have the absence of beer and the presence of wine, and you would also be happy. And in this particular example, it's a bit strange, but in this particular example, someone has poured beer and wine into your glass, and so you have the presence of both. And because you're not some kind of alcoholic sadist, that would actually make you feel sad. Now, if this were the way how your mood was determined by the presence or absence of beer or wine in your glass, then you could be said to be, your mood could be said to be defined by the XOR function, and this is short for the exclusive OR. So if we look at this table in a bit more detail, what we can see is that we are happy when we have either one of beer and wine, but we're not happy when there's no beer and wine, and we're not happy when there is both beer and wine. So this is a kind of hopefully comical example of what a function is. Now, what can perform this function? Well, we could say many things. This kind of silly thing that I've put up here is some Python code. So if we wrote and run this function, and we basically run the function in different scenarios where the presence of wine is either the presence of beer or wine is either true or false, then this function also implements the exclusive OR function. There are many ways to write this in code. I just happen to write it like this way because it's kind of clear. Don't need you to learn Python in order to understand this. Now, here's something that I hope you find a bit freaky. You could also make a computer which implements the exclusive OR function using dominoes. So maybe pause the video and run through in your mind, do some mental simulation of what would happen in terms of the output. Is the last domino standing or has it fallen down based upon certain inputs? So feel free to pause the video. But basically, if you think this through, this will also implement the exclusive OR function. I won't go through every single combination, but you should see that if you were to topple one and only one of the inputs, then it means that the output domino will also end up flat. But if you were to topple neither or both of the inputs, then the output domino would remain standing. So this is kind of interesting. I've attempted to define a computer as a thing that performs a function, and I don't mean function in terms of what purpose does it serve. I mean a function in terms of taking some inputs and translating those into a series of outputs. I've shown you a real-world example using the exclusive OR function, and this is an exceedingly simple kind of thing. The idea, though, is that by combining lots of different simple functions, you can maybe build up quite complicated behavior. We might talk about that in another video. So I want to conclude with just reflecting on this. So if we're saying that computing is about inputs and outputs, how could we proceed? Well, you could proceed if you were a behaviorist and you had an awful lot of time on your hands. What you could do is you could run lots of experiments where you get a willing volunteer who is your black box, and you can expose them to many, many different types of inputs. So you can imagine there are so many different situations that you have been in your life that it would take an awful long time to try to run this in an experimental setting. But let's just say conceptually that you did. You exposed someone to a whole bunch of different scenarios and you watched what happened in terms of the output. What would you get? Well, you would get a very long Excel spreadsheet of lists of inputs and lists of outputs. And it wouldn't only be an exceedingly long spreadsheet in terms of the number of rows, the number of different types of inputs, but it would be an exceedingly wide spreadsheet because you might have a column, for example, for lots of different things, like what's the temperature? Is it windy? Did you eat chocolate yesterday? There are so many possible states of the world that you could experiment over that this would be, well, firstly, practically impossible. So if we step away from conceptual land, it would be practically impossible. But also you could ask yourself, does this constitute understanding? This question that I've posed to you, some of you might actually recognize as a variant of Searle's Chinese room dilemma, but that's more about kind of consciousness. Here I'm talking about understanding. So in contrast, rather than building up this impossibly large spreadsheet, what you could do instead is to essentially say, no, I'm going to peer inside the black box and I'm going to do a smaller, much more manageable set of experiments where I place my willing participant under different scenarios and I maybe make predictions about what they're going to do beforehand based upon certain ideas that I have about the processes that are going on inside the black box. And so that would be a much more efficient way of doing things, but it would also be totally different. Rather than listing a ridiculous set of inputs and outputs, what you're doing now is you're focusing your efforts on what are the processes that are happening inside the black box. So that's the end of my video. I've talked about quite a lot of different things. Of course, there are going to be many remaining questions about what a computer is, and I am in no way pretending that I have formally defined what computing is. Not at all. Instead, what I hope I've provided in this video is a reasonably sane, reasonably understandable explanation of what a computer is, and relate that back to the ideas that we've got about black boxes, stimuli responses, but also internal mental processes that are happening inside the black box. So, hope that was useful.